Hello class, this is part 2 of the Thanksgiving assignment solution. Now, let us look at this one together. So this is the given equation, and then we want to find out the first derivative. And also, oops, yes, we want to go back to this one. And then the second derivative. Alright, since one straightforward way of doing it would have been simply this. Since y is equal to 2, e to the cosine of x, dy over dx would have been simply 2 times e to the cosine of x, same as it is, and multiply by through the chain rule, derivative of cosine of x, which will be simply equal to negative sine of x. When we simplify this one, we end up getting negative 2 sine of x e to the cosine of x. Now, that's the first answer. Second portion, the double derivative. We just need to find the derivative of this one. So negative 2 stays as it is. Now, first we can take the derivative of sine of x, which basically means cosine of x times the second portion, e to the cosine of x, plus having the sine of x as it is, derivative of e to the cosine of x, which we figured it out from here already. Hence, I'm just going to write it up right here, e to the cosine of x times negative sine of x. Now, then let us simplify this one a bit further. Then I'm just going to keep negative 2 as it is. And I realized that here we have cosine of x, e to the cosine of x common in both of them. So we will be taking that out. Negative 2, whoops, I'm just going to rewrite this one as cosine of x. After we take that out, then we end up getting cosine of x from the first portion minus sine squared of x. So that's basically what we end up getting. Now, given that, let's try to answer the second one. But the thing is, in this case, we are looking at if x and y both varies with the time. Okay? Now, then in this case, we are implying that x and y are in terms of time t. And essentially we are looking at the related rates. So let us try to look at it. Then our first, where y becomes 2 e to the cosine of x, doesn't quite become this one. As you realized further, our left side becomes dy over dt. On our right side, we will end up getting 2 e to the cosine of x times the derivative of this, which will be negation sine of x. But derivative innermost, which will be dx dt. Now, but at this particular case, one thing that we get to realize is that when x, we are looking for dy dt becomes 5 unit, and then when x equals pi over 2, let us try to put them in together and see what happens. So dy dt would have been equal to 5, if you noticed. Now we have 2 times e to the cosine of pi over 2. Notice cosine of pi over 2 is equal to 0. Now times negative sine of pi over 2. We also realize what that value would have been, and then dx over dt. Now then, here we get to realize is this Left side is still 5, but the right side 2 stays, and this portion becomes 1, and this portion becomes -1, and dx dt. Meaning the x dt will now simplify to 5 over -2. Now, don't forget the unit. Unit must be what? Units per second. So therefore, and notice that it is the word changing. That means you can write down that our conclusive statement will be x is decreasing. At the rate of 5/2 units per second. All right. So that becomes our solution for the first question. Let us move on to the second question. Now, this is in fact quite interesting question. I really like this one a lot. So let us try to look into this question. Some of you guys might be feeling that what's going on, especially in part B, but we'll try to explore them through very, very soon. Now, these are the given conditions. First, it says if A is equal to 1 and B is equal to 2, find the value of K. All we have to do is just simply plug them in and then see what happens. A. So f of A is equal to 1, so 1 plus 2 minus f of 1 should be equal to K times A is equal to 1, B is equal to 2, plus 2 times 2 squared. Then let us look at it on the left side. This becomes f of 3, which must be 21, minus f of 1, is that it? 5. How about here? This becomes simply 2k, and here plus 8. Now then we get to realize 2k must be equal to, here it becomes 16, but subtracting 8 we get 8, where k is equal to 4. That is our first answer. How about the second one? F prime of 3. Now, here we need to notice this portion for a second. And relationship to f prime. In fact, it is very important for us to realize that f prime of x is equal to limit as h approaches 0 for f of x plus h, as we know, minus f of x. This is very common, and then this in fact is very this was very easy for many people to recognize. But on this question, what they have done is instead of using x and h, they use the letter a and b. So if you're to use that, and here we get to realize something quite interesting. So I like to use red color to show you that f prime of a. How about that? All right, this a is not necessarily the same a as the previous one, but I'm just going to use a as a constant. A and a instead of h. What if you have to call it as b? B. B. How about that? Right? Now, then, as the question asked, when the question is looking for f prime of 3, simply means we're looking for limit as b approaches 0 for f of 3 plus b minus f of f of 3, my bad, over b. Now you might wonder, how do you calculate the top portion? In fact, top portion, they told us what it was already from here. So by putting this onto the location that's given here, then we get to realize limit as b approaches 0. The bottom one is still b, but upper portion is now becomes KAB, but remember k was 4, and then a is equal to 3, then we get to realize 4 times 3 times b, which is equal to, we have no idea. So 4 times 3 times b will be equal to k times a times b, and plus 2b squared. 2b squared. Since b is common, as we factor and cancel them out, we get to realize 12 plus 2b. And as b approaches 0, we get to realize this one to be 12. Hence, our answer for f prime of 3 will be equal to 12. That was answer B. Number C, find f prime of x. So even on this case, we will be using the exactly same strategy. Instead of a, we'll be using x. So let us try to look into that. F prime of x now is equal to limit as f of x plus b. Notice that I'm just going to use b because of the previous question, minus f of x all over b as b approaches 0. Notice that in place of a, we have b x, as you can see right here. Now, but this expression can be rewritten in this way using k equal to 4. Then now my expression will be equal to limit. Here we get 4 times x times b. Remember? Minus, or was it plus? In fact, let's check it out one more time. I guess it was plus 2 b squared all over b as b approaches 0. Now, when you simplify them, then we get to the limit as b approaches 0, 4, here we get 4x minus 2b. Then our final answer becomes 4x. Now that was equal to f prime of x. Now, in fact, this portion we didn't get to do that in class yet, but we'll try to just answer that for the argument's sake. Since this is f prime of x, then what would have been f of x? Now the fact that you got 4x as its derivative, then original function must have something like this, 2x squared, right? But we don't know about the constant. There must be some, there could have been some number on the last spot, which might have canceled out to be equal to 0. In order for us to find that, all we have to do is plug in one value right here, maybe 1 comma 5. Then we get to realize that f of 1 must be equal to 2 times 1 squared plus, let's call that was c. But we realize that that was equal to 5. Then here we get to realize c is equal to 3. Hence our final answer would have been this. 2x squared plus 3 would have been our expression for f of x.